All right, relative and absolute extrema on an interval. So this unit, especially in the beginning here, we're going to have a lot of definitions. Today, right now, one of them being relative extrema and the other one being absolute extrema. There's going to be a lot of similarities and also some differences between the two, as well as the other vocabulary terms that we're going to learn. So hopefully we do a nice job of understanding their definitions and also understanding their differences. Okay, so let's let f be defined on an interval I containing c. F of c is the absolute minimum of f on I if f of c is less than or equal to f of x for all x in I. And f of c is the absolute maximum of f on I if f of c is greater than or equal to f of x for all x in I. Okay, so I know that that's a bit wordy here. The key thing to know is that we are talking about absolute min and absolute max. Okay, absolute. All this is saying in terms of like the interval I is that, for example, the absolute minimum is lower than or equal to everything on this interval. Okay, which makes sense. I mean, think about a quadratic, that vertex, a positive quadratic. The vertex would be the absolute minimum value. Now think about like a horizontal line, for example. Everything is technically an absolute minimum because it's all less than or equal to all of its other values on its interval. The same thing applies to absolute maximum. So, you know, it has to be the absolute max, it has to be the highest or equal to the highest for all f of x that's in its interval, for all x in its interval. And same with that horizontal line scenario. If it was a horizontal line, technically everything would be equal to everything. So that everything would be an absolute max as well. Okay. So as it says here, max and min are considered to be extrema on the interval. Okay, so if we ask you to list all the extrema, for example, we are asking you to find the absolute max and min. Now, we have what's called the extreme value theorem. Okay, extreme value theorem, EVT. And here's what the EVT says. It says if f is continuous, so the function's continuous, on the closed interval a to b, then f has both a minimum and a maximum on that interval. So let's think about what this is saying. So we know this is a condition that must be true in order for this to be true. The condition is that f is continuous on the closed interval a to b. So notice that this does include the endpoints. Since it includes the endpoints, then f has both a max and a min on the interval. All right, so last definitions for this video here. It says if there is an open interval containing c on which f of c is a maximum, then f of c is called a relative max. And if there is an open interval containing c on which f of c is a minimum, then f of c is called a relative minimum. Okay, so basically what this is saying, now notice here that the difference is that we have an open interval in comparison to before we had a closed interval. So what this is saying is that a relative max or min and an absolute max or min can occur at the same location, really depending on the scenario, right? Now, we would not have a relative max or min on the endpoints, which is why we specify that it's on an open interval. So, in conclusion, we have absolute max and mins. They are the highest and lowest points on a graph, and that could be on an open or closed interval. When we're talking about relative, that's the highest or lowest point on an open interval only, not closed. Can't be an endpoint.